Hi everyone. We need to work next on adding and subtracting rational expressions. So we've already gotten to talk about the fact that adding and subtracting can be the tricky one. A lot of times multiplying and dividing actually ends up being easier. And anytime we throw addition and subtraction in the mix, we have to be really careful. But we do have one kind of underlying core principle that we need to use. You can only add things that are like terms. You can only count up things that are the same. We don't add apples and oranges sort of thing, right? So just to get us started, I want to walk through how that looks when there are variables in the problem. So these first three, well, the first one is just numbers. So remember, if you already have a common denominator, then you already have like terms. So this is like saying I have, pen switching to the wrong thing all the time. 5 1/3, and I'm taking away 1 1/3. So I'm going to be left with 4 1/3. So the fact that the pieces are both the same size, the pieces are both thirds, is what allows me to count up how many I have when I'm all done. Similarly, if I have 3 over w plus 8 over w, I can think of that as 3 1 over w's plus 8 more 1 over w's, which is a grand total of 11 1 over w's, otherwise known as 11 over w's. So yes, the way this works is if the denominator is the same, you add numerators, but this is why it works that way, because the denominator is just representing how big of a piece you have, and the numerator is telling me how many I have. So 3 1 over w's plus 8 1 over w's is 11 1 over w's. And even as this gets messier, if I have 3k minus 1, 1 over 4k minus 1s, and I subtract 7k minus 2 times, or 1 over 4k minus 1s, then what I want to do is just combine those coefficients, but it starts to look a little scarier to write it this way. So I think at this point I'd go back, hopefully with the understanding of what it means, and say, okay, well, if I have the same size denominator, that means my pieces are the same, and really all I need to do is add numerators, which represent how many of the pieces we have. So I have 3k minus 1 of them, and I need to subtract 7k minus 2 of them. The parentheses in this problem, one of them anyways, is going to end up being really important because that minus sign will need to distribute. So I would just remind you that fraction bars are grouping symbols, so there are always implied parentheses in these problems. So if in doubt, you are never wrong to put parentheses around the top and bottom of a fraction. That would always be valid. So I get 3k minus 1 minus 7k plus 2 divided by 4k minus 1. 3k minus 7k, so even in the top I get back to my like terms. I have 3k's, I take 7 of them away, I have a negative 4k. Negative 1 plus 2 is 1. Ooh, I think I like what I'm seeing. And we're out of like terms, so the question now would just be, can we simplify? And as it is, it's tempting to cancel out 4k's, cross out 4k's, or cross out 1's, but remember that canceling would be saying I'm dividing them out, and dividing isn't the inverse operation for addition or subtraction. So I can do something because that sign is just switched, negative 4k on the top, 4k on the bottom, positive 1 on the top, negative 1 on the bottom. I can factor out that minus sign. Oops, I'm doing it wrong though. Factored it out so it's not attached to the 4k anymore. So remember, if you're not sure you did it right, you can always distribute back in to check it. I get negative 4k plus 1. That's exactly what I wanted. And notice I now do have a 4k minus 1 top and bottom that I can cancel. This minus sign, remember those are attached by multiplication. So I'm left with a negative 1 in the top and a 1 in the bottom, which is just negative 1. So again, I think these are kind of impressive if you step back and look at what we're really saying. We do have an exception here. It's not okay for k to be 1/4, because then we'd have 0 in the bottom. But for any other k, what this is telling me is you plug in any number but -1/4, that subtraction problem is always going to give you -1. Unless you pick the bad k, you're always going to get -1 out of that. Okay, so that's how it looks for fractions that already have a common denominator. Next, we'll look at fractions that do not, and that's where this gets a little challenging.